Okay, thank you for coming to class. And we would like next week we'll have our test, and we'll likely test on everything up to and including today. And I guess some of you may want me to test less so that you don't have to study as much. But then I think my thinking is you should not be studying last minute. Like all the stuff that you've been learning, hopefully you should be learning every week rather than try to learn things in past 11 weeks in just 1 week, just before the test. So the idea is to let you make sure that in the future you will study everything, you learn everything every week. Okay, so let's go through very quickly what we have learned last week on this important topic of testing. We first saw the importance of software quality. It can mean losing business if you have bad software, and it can also means killing lives, or sometimes hardware problems is actually also related to the software problem that we see, because today hardwares are getting very, very complex. So it's not uncommon for hardware to have some problems too. So, and we looked at why testing are getting more and more sophisticated, more and more difficult, because programs no longer run stand alone as a sequential program, but they interact with each other. Parallel programs work with each other. And we've learned that by doing code review, having a group of people together looking at one person's work, it could be could be coding, it could be other document, design document too. Then code review or inspections is the approach we use to improve without testing. And we have looked at different types of software testings. This is roughly the order to do it. First, the programmers do the unit testing, and then increasingly, testers may be getting more involved in the middle bunch. And then later on, users would also be getting involved in more of the later testing. But depending on the size of your team, if you have a small size, then a person may be asked to do many different types of testing. Okay, but it's a good idea that everyone cares about software quality. Okay, so the programmer should feel that it is their pride to deliver quality work. But we know, just like how corruption, let me use the corruption problem in Hong Kong like 40, 50 years ago. Used to be the anti-corruption department is in police, but then you are asking police to investigate other police, then they don't do that objectively. In the same way, programmers, if we are the only person who tests our software, there's a good chance that we overlook, we cannot see some potential problems. So it is good to have a separate group of specialists that look after testing. And I share with you that at IBM, the testing team is perhaps 2/3 the size of the development team. So you can see how serious, if you are into a product business, you're delivering software product, then it's a good idea for you to have a strong, a sizable testing team. So we've seen unit testing try to test software by isolation. So you isolate one class or even just one method. Um, and then when you integrate things together, different components get together, you try to check if they interface correctly. And that kind of testing is called integration testing. And functional testing is about how what kind of features it has, the functions. But non-functional testing correspond roughly to the quality requirements. For example, how fast it is, how reliable it is, or how much work it can do in a short time. So those are non-functional testing. And then user acceptance testing is the final testing before we turn over things to the customers. So after customers sign off, then everything will be considered bug fixes at that point. Okay. So generally, the user would be quite careful, and they don't want to accept things that are not of good quality. So there's also usability tests, how easy it is to learn, to use, or to use it effectively, efficiently, and reliably. And regression tests is to test whether a new modification introduced new bugs, because modification may be adding new feature, may be fixing a bug, but you don't want to fix one bug and then introduce three. That you're not progressing. Okay, so we looked at some testing terminology. Test suite is a collection of test cases, and each test case has some specific values that we want to test. And today we're going to look at test cases in more detail. And test scripts are just description of test cases. Some of them are automated. Some of the test scripts may be manually done. But how do we know what result to expect from an input data? We use something called Oracle. Lots of time, on Oracle would be some documents, and other times it would be an on-site customers who would tell you what he or she wants. And sometimes in the case of a compiler, then a working compiler that may not be very fast, may not be available on all platforms, may be the Oracle. So if someone wants to re-implement the compiler to make it faster, to make it run on more platform, or to give more cool optimization feature to this compiler. For example, optimize the code for speed or for smaller size, then they would rely on an actually working compiler. Sometimes, okay, it depends. Sometimes we still use documents as an Oracle. So Oracle is whatever mechanism. It could be a program, it could be a document to tell us whether for a given test, what result we're expecting. Okay, so and we told you that there are two main categories of testing. There's the black box testing that we only focus on what input data produces what output data, and that's black box. But with white box, we try to look inside the program to see the program. So we would look into that today. So that's our review for last week. So let's look at specific testing techniques. We would look at these four, and then one more at the end of the class. So let's begin with these four. Equivalence testing, boundary testing, path testing, and state-based testing. Equivalence testing is also called equivalence partitioning. So partitioning means divide. You divide things up into different categories. But first, why do we need testing technique? Okay, can we just go randomly to test things? Well, the problem with randomness is that maybe you're not giving it the right test data. So how do we choose test data like to test our program? So with partitioning, we try to look for some characteristics in the input test data, and then we divide it up. Okay, so let's take the example of a password facility. Okay, for example, we've all used password updating features of our like Facebook or Gmail or whatever account. And first, we can think of two partitions: correct password or acceptable password, or unacceptable password. Okay, so valid password and invalid password. But we can, this is hardly enough. So we want to divide it up into smaller categories. Okay. So the next slide will show how we can divide it up more. Okay, so maybe suppose your Gmail account or whatever account allowed you password length from 6 characters to 12 characters. Okay, so if you just input a 5-character password, they will say that, oh, it's too short, it's unacceptable. Okay, and if you put 300 characters as your password, they think you probably made the mistake, so that's too long. So we can now repetition the previous one of valid and invalid to now valid and invalid for different reasons. One reason is perhaps it has not enough characters, and the other one means it has too many, and the last one is that maybe it contains unacceptable characters. But of course, newer password checker, they accept more special characters, punctuations, because they think it actually makes the password safer, right? Because why limit it to alphabetic or just alphanumeric? Well, if you add exclamation, parenthesis, $sign, that's even better because more combinations and harder to guess. So now, if you look at here, we can think of it as one partition, 6 character, 7 character, 8 character, 9 character, and so on. So 2, 4, 6, 7, 8, 9, 10. So now we can have 10 categories in total, involving 7 for valid and 3 for invalid. So, so how will it help us? Okay, when you are testing, when you are choosing a password to test, then if you choose a 7-character password to check, then we may want to make the assumption that your software, your password checker that you're writing will behave the same for this 7-character password, just the same as any other 7-character password. Okay, so the idea is, well, if you are picking one member in this set, then other members in the whole set will give you similar result. So if you accept this 6-character password, likely you will accept another 6-character password. And if it rejects this 3-character password for being too short, then you're thinking, maybe my software checker, the password checker internally will reject other 3 character in addition to the one that I'm testing。咁嗰個成個嘅 idea 咧就係話，我哋想其中一個點解用 testing 嘅 technique 咧，就係想我哋用最少嘅 test data 就可以最有效、最大機會咁樣揾到，假如我哋個 program 有 bug。咁所以咧，正話嗰個 case 咧就係、我哋將佢咁樣分滿，即係分咗一個個 partition。咁即係話咧，我哋可能好有效咁樣10個即係 password， 每一個 partition 揀一個出嚟，咁就做咗我哋嗰個嘅個 test data。咁10個相對嚟講咧，就好過我哋亂咁即係亂咁揾啲 data。可能我哋會亂咁揾嘅 data 咧，全部都係集中晒喺呢度咁先算啦。咁我哋可能都冇乜 test 過。如果我哋個 password checker 如果遇到啲 invalid password 嘅時候會點係嘛？咁所以咧，我哋就係希望好有效咁樣分。咁但係咧，so this is basically what I have said in this next slide. So, but we say that actually there are different ways to partition our test data. For example, this is one way to have 10 partitions, but maybe we want to further divide up the invalid characters. For example, perhaps you are thinking as a programmer, you are thinking, maybe my program will be able to accept space character, and maybe you don't want to accept it. So you want to check your special character with space and without space. And also maybe you have nowadays password often require you to have at least one upper character, one lowercase character, and one digit and one punctuation. So if we take those into consideration, we will likely have more partitions, okay? But the idea is to choose a set of test data so that assuming a similar member in the same set, in the same partition will give similar result, then you can test your software quite thoroughly with a small number of test cases. So it's probably, if we look at case by case, it's probably more beneficial for you to do this type of equivalence testing than to do random testing. Okay, so of course, 我哋都另外有一種嘅 testing technique， 我哋呢度就冇講嘅，即係我哋呢個 course 就係 exploratory testing， 即係真係揾個人去亂咁試下咁樣，即係唔係話嗰啲亂試嘅 testing 係冇功效。特別我哋依家有講過話，好多時係啲 software 唔得咧，係因為個 parallel program 嘅 behaviour 即係佢 catch 唔到，咁所以嗰啲亂試咧亦都有佢嘅 value， 但係咧 it does not replace this sort of systematic way of testing thing. Okay, so that's equivalence testing. Another technique we often use together is called boundary testing. Okay, what it tries to say is, well, remember here we say whether it's 0, 1, 2, 3, 4, 5 characters are all too short. If I ask you which length will likely cause problem, 你會覺得邊一個嘅長度 會最容易喺呢個 password checker 嗰度咧，即係我當你而家寫嘅係就係 password checker，會 check 錯或者唔識得 reject 嘅。OK， 邊一個會最容易佢會 check 漏咧？有冇人有啲嘢估嘅地方？其實最大機會咧，通常就係一頭一尾，即係佢可能 check 晒一個、兩個、三個、四個，但係可能唔記得 check。如果零嘅 character 係點樣？即係有時會漏呢啲。咁另外一個可能性咧，就係同我哋講過話，記唔記得上一堂咧？我哋有講過叫 mutation， 我係咪？咦，我唔係同你呢班講喎 mutation testing， 你冇講過嗬 ？OK， 冇聽過呢個 mutation testing。咁just forget about the term， 因為呢我諗係我教咗362嘅。OK 嗱 ，just imagine 你而家係寫緊一個 while loop， 即係或者有一個 loop 你係或者有個 if statement。Imagine you have an if statement to check if the length of the password is less than something something, then you flag the error saying it's too short。幾時你會有機會錯咧？就係、是、你嗰個 if 嗰個 condition 咧 ，instead of 用咗 less than or equal， 你可能用咗 less than 咧。咁所以如果你 if you make that kind of mistake, maybe even you're not supposed to accept 5 character, you may still accept 5 character because when you compare the length, you use the wrong relational operator. Like less than or equal, you use less than by mistake. So that is the whole idea behind this is called boundary testing. So boundary testing try to look for boundary values. So if we think of this as one big category, so if we are just considering one big category here or one big category here, we want to check what happens with 5 character, what happens with 0 character. We may not need to check 1, 2, 3, 4 because they are not at the boundary. So usually if you have both sides of the boundary, if it works correctly, it probably would work in the middle. So your test data. So another way to enhance the equivalence partitioning is you focus on the boundary, near the boundary. So that's the meaning of boundary testing. So generally, boundary testing almost always assume the context of equivalence testing. So you look for the boundary of the partition. Okay. Another testing is called path testing. Okay, unlike the previous 2 testing, boundary testing and equivalence testing, the first 2 are black box testing. Black box meaning that we only look at the input data and we only look at the output data, just those 2. We don't look at the code, okay? We don't know and we don't care. But with path testing, we actually look inside the code. If your code looks like this on the left-hand side, it looks for if x greater than 0, you do a group of statement, A1. Else, you do another group of statement, A2. And if y is greater than 0, you do B1 statement. And otherwise, you do B2. So based on the value of x and y, okay, you can, if x equals 1, y equals 1, then it will do A1 and B1. If x equals 1, y equals minus 1, then it will do A1, and since it's minus 1, it's not greater than 0, it will do B2, so which is here. So in this case, 2 if statement, one after another, to thoroughly to exhaust the 2 different branches, you would Okay, sorry. So you would need to devise your test data with X and Y, you give it proper value. So you need 4 test cases to exhaust them. So that's path testing. And well, in case, oh, sorry, I somehow I use OneDrive to update, and I use my work computer. So I added a slide, but it's not here. But I'll later update it. 其中一個，你有冇同學用 OneDrive 㗎？你有冇 Dropbox 咧？你哋唔使用呢啲嘢㗎。OK， 因為學校嗰個已經夠用。Yeah, because we're in software engineering, so we probably want to talk a little bit more about software quality. Perhaps because Dropbox was the first to provide that service. Dropbox has way better performance in terms of I update it on one machine and then it's updated on the other machine. But OneDrive, the updating process, the synchronization took longer. So I'm disappointed that it's still not updated. I add another slide of path testing. Path testing, I want to add that 如果我有個 while loop while 一個 condition， 然之後做第二啲嘢嘅時候咧，咁如果用 path testing 嘅時候咧，我哋要知道嗰個 while 嘅 condition 咧，其中一次咧係要 true， 亦都有一次係 false。因為如果佢係 false 嘅時候咧，就即係話嗰個 while 乜嘢嘅 body 咧，嗰個 body 係從來都冇 execute 過嘅。咁然之後有一次 true 咧，就係話咧佢係會有 execute 過。咁所以path testing 咧。無論係 if then else 或者係 while 或者咁咧，呢啲越長嘅時候咧 ，very likely you will need more cases to test, but you need to look inside the code to devise your test data. Okay, so it's a little bit more complex. Also, there is another type of test tool, because remember, we have this term called test suite, right? Test suite is a collection of test cases. There are some testing tools that tell us, given our test case, which statement we have covered. 即係話換句話講，嗰啲 test tool 咧可以話俾我哋聽 ，given 你俾我嗰堆嘅 test data 有。喺個 SUT 嗰度咧，有邊啲 code 係冇 run 過、冇 test 過嘅 ？OK， 嗱咁呢一個咧係有一個好處嘅，呢一啲咁嘅工具咧就可以等你你睇到原來你 test 漏咗一啲 code 過，但係呢啲你可以 check 下，如果呢啲唔係 suppose 係死嘅 code， 即係話唔係，如果佢係永遠唔會 execute 嘅 code， 咁你應該其實拎走啦。如果係嘅話咧，如果佢係應該 execute 嘅 code 嘅話，即係話。我哋寫個 test case 咧，亦都要 execute 埋，即係嗰啲 code。咁呢個亦都係關於test coverage 嘅問題，即係有一啲嘅工具係可以幫我哋咧去睇下我哋嘅 code 嗰度係唔係 fully coverage。但係 fully coverage 咧同埋 path testing 都有少少唔同嘅，因為 fully coverage 咧就只係話 require 咧，我每一行嘅 statement 咧我都有 test data 去 go through， 但係 path testing 咧。係仲要 require 多啲，就係咧唔同嘅組合嚇，因為如果我淨係話要cover 晒，即係4A1、A2、B1、B2 都 test 晒嘅話咧，其實我只需要攞 test case 1同埋 test case 4咧，就已經可以 test 晒4段曲都有機會 run 過俾個 test data。但係 path testing 咧，通常我哋係想要仲thorough 一啲，即係話唔同嘅組合，即係話 A1 夾 B1 又得 ，A1 夾 B2 都要想試埋，或者 A2 夾 B1 又要試 ，A2 夾 B2 又都要試咁樣，即係所以 path testing 咧係有即係 It's a little bit more than just every line has to be executed, but we have tool to help us to do that. Okay. State-based testing. This is slightly less used than the other ones. I'm trying to teach you the one more important first. Um, if your object can be in different states, you want to, and also if its behavior can be shown with a diagram like this, a state chart diagram like this, then you want to have test data to make sure that you actually test your object at each state. And you also want to have data to test each transition. Okay, so every arrows has to go through. For example, if the state is on, you want to test this turn on while it's on, or you want to try turn off while it is on. So to make sure that it will not all go to the other state by mistake. So this is still if for state-based object is still important. So let's take a short break. Let's take a short break.